Good morning, everyone. Welcome to my talk about. Sorry, I'm a bit nervous. About generating impact with data. So we had a wonderful talk about the whole scope, how we can, how we should build a data science project at the end. And I will show you how we, as Lampenwelt, are right now on the journey towards a data-driven company. I'm personally a data scientist in the company. We have a team of also T-shape, we have data engineers, BI analysts, also DevOps, which are all working together. And today I will talk I will introduce the company shortly, show you how our legacy architecture is looking like, our data warehouse, and how we are now moving towards a data-driven company. And at the end I have some data science use case and some of the approaches that we want to do in the future. So if you probably go on the web and want to buy some light, you will probably stumble upon Lampenwelt. It was founded in 2004. It was a really small family business based in the garage, selling lamps over eBay first. Also coming with a shop later. Now you see we have over 20 countries, also some marketplaces all across Europe, in all the core markets. So we are presented everywhere, and this leads us that we have over 60,000 just lamps and luminaries. We have from over 500 suppliers. This brings us that we need a big warehousing solution in the logistic, where we have just a folder around 30,000 pallet spaces. And with all of this, we come up with over 2.5 million parcels delivered in a year across Europe. So this is the motivational part, and now we need a good data solution, data architecture, data warehousing to handle and scale well throughout the years, and we are still growing. So let's first probably discuss what is a data-driven company, what has driven us to go this way. So we need, from this data that we collect from different sources, fast and powerful insights, of course. We then want to use those insights to do our decisions. Not only just based by looking at the Excel table and thinking that it makes sense to improve campaign, but also based on the data that we have. Then of course, as mentioned before, we want to do more machine learning and predict some trends, maybe for purchasing more products, and also reduce the data silos that we have throughout the company. And for that we need a central data strategy. So on the timeline, we started in 2004, and at the beginning it was mostly different tools that we used, like ERP system and Google Analytics and more, and people were just preparing their analytics and reports from there, exported to Excel, and like you do at the beginning with a small data. But then we started really building a general, more automatized ETL solution and reporting that will help us to process all the data that we have in 2016. And a very basic concept how it looked like, that we have on the left, we have multiple sources, so there's a lot of there. To mention some, like for example Google Analytics, Google Ads, Facebook, Salesforce, whatever else, any other databases or incoming event data like from Kafka. And we have our local machines running with some database, and the data was ingested into those databases, processed, conceptually it's shown in here in the middle. And then of course we need some kind of self-service for the people to see, have some insights, first insights. And this is presented here in the presentation part, where we copy our data from the ETL process into this another machine on premise also. And so we had some two solutions. we have one is our dashboarding solution built by the data engineers, and some open source. Maybe some of you know is a Psycho. It's like self-service opportunity, also with the possibility to export the data to Excel. And on the top we had some insights that were going from the ETL process directly into Salesforce, like marketing campaigns and different other sources, also back to the systems over Kafka, for example. So while this was a very huge help at the beginning already, we were able to process much more data. The data was still growing, we were expanding, and then we discovered some drawbacks of this setup. And these were that we had our whole storage and compute like combined. So we are a bit blocked in parallelizing this. So you can increase your machines like vertically but not horizontally. So horizontal scaling is important. For this we need to have a separation between storage and compute. As shown before, we had our data copied from ETL server to presentation server, which costs time. Streaming capabilities were like almost not there. Also on the other side, there was kind of an analytical bottleneck where the self-service was already there, but every time you need a new dashboard, a data engineer has to build it. So we were mostly doing some preparing self-service for the analysts. And yeah, in this setup, we had like no real resources for data science and machine learning, which we were mostly doing data analysis on the local machine, so also need to export the data first. So it's not really a good approach for ML ops. That's where we started the first step to go towards data-driven approach, and we started that with replacing our dashboarding solution from the self-hosted one to a cloud-based. So what changes here? Everything is mostly the same, except for this part on the right, where we moved. So we still need to copy the data, but we now copy the data to an S3 service, so by AWS. So yeah, in my presentation we will see a bunch of tools. We had the question before. So in here we have a file-based system where we store the files just as Parquet files. This is our storage layer. In this case, we have Athena, which is a Presto-based distributed SQL engine which can query those files. And then at the end, we use a dashboarding tool by AWS QuickSight, where, and this is very important, where the analysts can build their dashboards themselves. So that was a huge leap forward already, as we have a separate compute engine here and we have a separate storage layer. But we knew we still have a big block in here, so we wanted to go further. And this year we started to move the whole complete data warehouse to the cloud and make it more scalable and also to achieve more data science applications. So again, here we'll see a lot of tools. Maybe you can ask later or in the talk. So the whole infrastructure in the middle is now based completely on the AWS. It can also be Azure, it doesn't matter, or Google Cloud. We use Databricks as our core element to build our data lake. And very important also, we use infrastructure as code by Terraform to provision all our infrastructure. On the bottom you will see we have like almost the similar pipeline that I've shown you before. So we have still S3, Athena, and QuickSight, but we changed from Parquet files to Delta files, which are also Parquet files, but with some logs, which enable ASIC transactions. So like a real database, and also like time travel, so you can really switch back if you have some wrong data. And now the interesting part, so now we can have multiple clusters as we're in the cloud and we have our storage layer, and we, for example, start our ingestion cluster, which just handles all the data sources and writes this down to our storage. Then we just spin off another cluster, which uses, in this example, dbt as an ETL tool to process the data, which was ingested into our data lake. And of course, it's then not a problem of resources to just spin another cluster and have some data science and machine learning applications. And as one more thing we also wanted to improve, as we were changing so many stuff, we moved also some of our connectors that we were also self-hosting and managing. We moved many sources to 5trend solution, this third-party tool, which enables you to, which hosts all the connectors and ingest this directly into our data lake. So it also doesn't have to be this tool, you can also do this on yourself, but this saves us a lot of time. Yeah, so this is our concept that we have, and we are already on this, using all these tools, and it's working pretty well together. We also improving already the scalability of the system. And so what have we built? We have a scalable solution by means of separating storage and compute. We have a single source of truth, as we have everything in one place. And we want to encourage users, of course, to use this platform. So we improved our self-service by dashboarding, where we have analysts can simply go create their own dashboards. And also, as mentioned before, we use dbt, which also improves, helps advanced analysts, let's say that way, who can write some SQL code, yeah, improve the ETL pipeline and create new columns and some processing steps. Yeah, and at the end, all of this before helps us to reduce our work on the side of ingesting data and preparing dashboards, and we now can focus on data science and machine learning on application, which is what I'm about also to show. One very simple approach that we used already in our company. So we have a SEO team who wanted to distinguish B2B customers and B2C customers, because we want to improve their experience on the website. And they use the Google Search Console data, for which we have, for example, for Germany, around 40K search queries per day. So that's a lot. You don't want to do this manually, of course. And they used the UI of Google already and had some initial findings. And the one is like B2B customers mostly using the search during the weekdays. The second finding was they are using mostly desktop computers. So we thought, okay, we can at least start with automatizing this whole process, so help them. And so we decided, okay, let's go together and create those let's say, features based on the impressions. And from the data perspective, it looked like, so the B2B keyword, you see we have rises during the week and drops on the weekend, and it goes even mostly almost till zero. So it's really, really a B2B keyword, which is very clear. If we switch to a B2C keyword, you have some highs on the weekend, but it's also maybe not that clear that it's a B2C keyword. The most important part, as the topic was to distinguish B2B keywords, it's clear for this one. So we've built a pipeline that ingests the data, detects just the distinct keywords. For now we're working with single keywords and not the combination. We extract those features that I've just introduced, and we build a very, very simple ranking function to have just one value to say if it's a B2B keyword mostly or not. And the result was given to the main experts, who can then say, yes, this is right, this is wrong, so to have some feedback And the most important part is that like this 4 steps were already built on the new platform, so they are all automatically ingesting data, extracting keywords, and doing the ranking, so we can do this for all other countries across Europe that we have. So if we have those 2 features, we just plotted them, and what you see here is that we have most of the keywords like a very dense cloud. And this is what we also awaited, because most of the keywords are B2C keywords. And I don't go into the details, but we really expected some of the B2B keywords to be in this corner. So we built a function that ranks them like that, and we expect keywords to be in this corner. And B2C keyword, of course, we have more B2C customers than B2B customers. So the result was we had around 11,000 keywords in 2 months for Germany, and like this first 100, I'm showing only 36. They were all those that are marked with color were directly very certain B2B keywords. Some were like we were still in discussion, but that was a very good result for us, and that's why we know that that was a success for us. So we have this pipeline, we can automatically run this for all the other countries where we maybe don't have domain experts that can directly do this pre-analysis. And of course we will extract more features, use them to really train a maybe better model on that, as shown us that we can really handle this data well. We have just to show what we want to do in the future. We have many projects that we want to start. We already started working with image similarity, as if you go to the website you will see we have a bunch of images, and we started working there. We have an own pricing engine. We are working on scheduled at least the next projects for trend forecasting, and also want to improve our shop performance by some recommendation systems, and maybe also based on the images that we have. Yeah, so to summarize, I hope I'm good in time. We moved our structure completely to the cloud. We can now really scale much better, as we were really on the limit with our previous infrastructure. And yeah, our self-service is getting better and better. And we reduced the data silos that we had, or we are reducing them, of course. Now it's ongoing business, and as shown as the data analysis example, we really improving our business values, and of course there is always more to come, and I'm really looking forward that we use this structure and yeah, have some more data science projects incoming. Yeah, that's all from my side, so if you have any questions, thank you for your attention.